Yo, what's up guys? Patrick here, moving on to another rate of change word problem. So we have an object, it's moving horizontally according to the equation d of t is equal to t cubed plus 20 over t plus 1 minus 20, where d is the distance in centimeters and t is the time in seconds. Two parts to this question. Part A, we have to find the average rate of change for the first 3 seconds. Then part B, what is the average rate of change during the 4th second? Okay, so part A, find the average rate of change for the first 3 seconds. So let's show sort of on a timeline how this looks like. So we have 0 seconds, then we have 1 second, 2 seconds, 3 seconds. So notice the average rate of change for the first 3 seconds is this whole interval right here. So we have to find the average rate of change from this point 3 and this point 0, or from this point 0 to this point 3. So the way we would do that is notice how this is a distance versus time equation, or a displacement versus time. So to find the average rate of change, we'll have to find the slope of the secant if we were to graph this out, which we won't do. This is a pretty complex graph. So to find the slope of the secant, we would find the distance at time 3 minus the distance at time 0 all over 3 seconds minus 0 seconds. And the way we find the distance at time 3, we just plug in 3 for the t value in the equation. So 3 to the power of 3 would give us 27. We'd have 3 plus 1 in the denominator here, so that would be 4. 20 over 4 is 5, so 27 plus 5 is 32. Minus 20 would give us 12. Right, so d of 3 is equal to 12, and then what's d of 0 going to be? Well, if we plug in 0 here, that goes away. This would be 0 plus 1, so it would be 20 over 1, which is 20, and then minus this 20, so it would be 0. And then we would still have 3 minus 0 in the denominator, so that would be 3. And then we'd have 12 over 3, which gives us 4. Now you also can't forget about your units, so notice how the numerator is in centimeters, right? This equation is in centimeters, and then the denominator is in time, so it is seconds. So our final answer, the units of it, is going to be 4 centimeters per second. And notice how that is a speed. And that makes sense because the rate of change of a distance versus time graph, or a distance versus time equation in this case, is speed. So 4 centimeters per second represents the average rate of change for the first 3 seconds, and don't forget your units. And then part B, we have to find the average rate of change during the 4th second. So let's keep this diagram, this timeline that I drew out. So what's the 4th second going to be? Well, notice how this interval here is the 1st second, 2nd second, 3rd second, and then the 4th second is going to be right here. So notice how it's between the points 4 and 3. So we're finding the average rate of change during the 4th second, so we're finding the average rate of change in this interval here. So basically, like we did in part A, it's just going to be between these two. So it's going to be d of 4 minus d of 3 all over 4 minus 3. Right? So we have to find the distance at the 4th second, subtract the distance at the 3rd second, and that's going to be all over this change in time, 4 seconds minus 3 seconds, which is just 1 second. So d of 3, we actually already found in part A. We know that that is 12. What's d of 4 going to be? Well, 4 cubed is going to be 64. And then 20 over 5, right? 4 plus 1, we'll have 5 in the denominator. So 20 over 5 is 4. Then minus 20 would give us 48. Yeah. So we'll have 48 all over 4 minus 3, which is just 1. right? So this is in seconds, and then the numerator is in centimeters. So we'll have 48 minus 12 centimeters, which is 36 centimeters over 1. So the average rate of change is going to be 36 centimeters per second. So that's the average rate of change during the 4th second for an object whose distance is modeled by that equation.